this image. So the first person that raises their hand after seeing this gets the other light that I live. We have a number of kids, and we always have kids' friends over, and we would play a game, and it was called Slam. And everybody would say, man, you should make this into a game that you would sell. Well, after like 20 years of people saying that, I did. So what you'll find is, it's like a mouse pad. There is a slammer. There's little mice that you pull out, and you roll dice. So the slammer has, you all are watching this. You have to get 7, 11, or doubles, and you pull out a little mouse, and the slammer tries to catch it. So I've had multiple people. I see a homeschooler over here. I've seen many people that use it as an outlet in math class. Like, if they do good, you get to play Slam. Well, it's a big deal. So the other person, you notice there's 2, that can show me a multiplication on this. Spiral. It's the other one. That's after class. Okay. So this is the image. You see it, hands go up. Okay. So in the next 35 minutes, I hope to explain to you what I do, how I got here, and then possibly what you could do. You did a great job, by the way, in your presentation. Excellent. I feel intimidated here, but I'll press on. What you can do for your students to have them in an engineering career. And again, you notice the title, structural engineering, from my perspective. I, only one individual, but I've been doing it for 35 years. I had a very interesting and kind of odd career path changes. The net result was I've done a lot of interesting things, but one individual. So just take that for what it's worth. And thank you for the opportunity for being here. Thank you, Dr. Shaw. It's a great opportunity. As I shared before, we actually have 9 kids, and 8 of them have attended here. And I think about 6 of them got their associates. A number of them have gone on to be number 1 in their class at TEP, William Mary, the New England Culinary Institute. My daughter that went to William Mary got a full ride, thanks to the staff here and her education here. And she said, Dad, really, LFCC professors were just as good, if not better, than at William Mary. So I shared that with Dr. Shaw. Just a word of encouragement. My family has benefited greatly by this institution. All right, let's go. So here it is. What do I do? How did I get here? And how do you help your students prepare? My life, and I don't know if they still use the concept word problems. They did when I was in school. Okay. Oh no, not a word problem. I got to apply the stuff you just taught me. Well, that's what I do every day. I am presented with a set of circumstances, and I have to deal with it. You might go ahead, just give you a little blurb here, just to maybe give a kind of a dramatic example of this happening. How many remember the movie Hotek?
Gene, we have a situation brewing with carbon dioxide.
We have a CO2 filter problem on the lunar module.
5 filters on the limb.
We come in for 2 guys for a day and a half.
So I told the doctor.
They're already up to 8 on the gauges. Anything over 15, you get impaired judgment, blackouts at the beginnings of brain asphyxia.
What about the scrubbers on the command module?
They take square cartridges.
The ones on the limb are round.
Tell me this isn't a government operation.
It's just isn't a contingency we remotely looked at.
Those CO2 levels are getting toxic.
Well, I suggest you gentlemen invent a way to put a square peg in a round hole. Right.
Okay, people, listen up. People upstairs, candidates this one, and we gotta come through. We gotta find a way to make this fit into the hole for this, using nothing but that. Let's get it organized. Get some coffee going, too.
So, really, not quite as dramatically as that, but that's my day. I have people call and say, I have this problem. And I have either this means, or I want this done with this. And so I, like them, have a box of tools. In my case, it's concrete, and all kinds of different types of concrete. Cast in place, which you're familiar with, footings and other things. Precast concrete, this is actually a client of mine. They have a whole set of precast buildings that are shipped around the country. Pre-stressed concrete, post-tension concrete, roller compacted concrete, fiber reinforced concrete, shotcrete, gunite. The list goes on. So that's my toolkit. That's the pile of stuff on the table. Next thing we get into, when I came to front well, my practice is at front well, and I told the gentleman at my table, I was sitting in a meeting with the Navy, and about 15 people around the table. My client said, well, he's not like somebody works out of his basement. Actually, I work in 17 states. I work in, 15 countries, a lot of places out of my basement. So I'll tell you the history of how I got into my basement. The first time, in 1995, I'm sitting in my office in Front Royal. A contractor comes in and says, I need an LVL beam design. What the heck's an LVL beam? I knew what a beam was, but I'd never heard of an LVL. So in 1995, my knowledge of wood was zero, but I've learned a lot. And every day, I design either residential or other types of structures using different kinds of wood. Timber frame, not as many, but I've dealt with many of them. Treated timber for all kinds of uses. Then we get into masonry, whether it's brick or stone. Concrete masonry units that always, when I start saying CMU to my clients, what are you talking about? And I say concrete blocks. Oh, okay. Segmental retaining walls. A major part of my life, as you'll see, was involved in retaining walls. Steel, I've done regular red iron steel, light gauge. The hotel across from Costco, I did that. It's all light gauge steel. Polymers for earth reinforcement. The images are a little light, but you can see on the end, I actually, as part of my work, and I'll explain how that happened, something around 15 different patents through the years that I developed. Then, of course, I turned over to the companies that I worked for. So, and one thing I worked with, believe it or not, my brother-in-law, was on a soil reinforcement, which we have patented, and it's similar to that one. I don't know if you can even see that, but in this case, this is a retaining wall with this whole part of the wall caved out, and that's how not to use polymers. Within my oh, okay. Very good. I'll do the last 10 minutes all over again. Thank you very much. So yes, and if you want to talk about that, I did nothing but retaining walls for 12 years, so I can talk to you here about retaining walls. I deal with dirt, and I like to just call it dirt because my geotech friends go nuts because it's just dirt. That's what they do. But in my function as a structural engineer, I, again, having worked 12 years in soil reinforcements, I'm dangerous enough to actually do some work with the soil mechanics. When it gets to a bigger project, I will bring in the geotech. This product that you see on the right with the precast panels, metal reinforcements, if you've been by the interchange in Gainesville recently. Yeah. In fact, if you ever go to Dulles Airport, anybody gone to Dulles Airport? Okay? Well, you went over one of my walls. So, if it ever fails, you can blame me. It's all the approach is over 28 and the tollway. That was me. And this is the product that's there. You see the cruciform shaped panels, which I'll show you later. So, I have an understanding of dirt. That's another thing in my toolkit. So, we've got all these materials, and they have all these properties. And obviously, you all have seen brick, and you've seen stone, and all these things. But how do you use it? How do you analyze it? That's from my training, my college education, my years of experience of coming in. So I'm not going to teach you all of engineering, but I thought I'd give you one opportunity here. One concept, moment of inertia, is extremely important. It's basically a measurement of the geometry. So if you see the analysis here, let's look at number 1 up there. It says increase the height of the web. You have a 33% increase in the moment of inertia. And if you look at the other options too, increase the flange width, this being the flange, and each of those are increasing by a square inch, the 7% increase. You increase the thickness of the flange without changing the height, 5%. Increase in web thickness, 1.8%. So when I talk to my clients, I say, if you can give me a deeper section to work with, I can do so much good for you. So that's just something I know. And let's see, I'll digress. On my professional engineering exam, one of the questions was, given these parameters, ignoring lateral torsional buckling, which is on that next to last line, you have a 1-inch plate. How big do the flanges have to be? I needed to get that question to pass the exam. So I ran through the numbers, and I came out, I didn't need flanges. And I said, they wouldn't do this on an exam. They wouldn't do this. So I went through 3, 4 times. I come up with 0 every time. I said, here goes, 0. I passed the exam. So that was a very nasty question. The other property, elastic modulus, is kind of like the hardness of the material. If you compare, well, there it is. Spruce pine fir is the typical lumber that you would see in any house. You look at the value for the modulus, for elasticity for that. Look at manufactured wood, which is those other materials. So by the engineered wood, you get almost a doubling of the capacity. But now you compare that to steel. Yeah, it's 15 times as strong, 30 times as strong as wood. You can see why steel in long spans is very important. And that's why we go to that. Somebody comes and says, I want to do this out of aluminum. I said, well, it's only a third as strong as steel. So, all right, here's your one problem you're going to have to work out. So, when I'm analyzing the amount of deflection in a beam that is uniformly loaded, so the load is continuous along the whole beam, and supported at the ends, I would be using this formula typically. So it's 5 times W, and W stands for the uniform load, like maybe 100 pounds per linear foot or 1,000 pounds per linear foot, times the length of that span for the 4th power, divided by 384, which is just a constant, and divided by E, which is that hardness factor, and I, which is that property that talks about how deep it is, how wide it is, and all that. So what value? Okay, so E and I are directly proportional, correct? So I got twice as big, it would have the deflection. If E got twice as big, it would have it. So what if L, and this is a direct quote from a contractor, will it matter much that I use those calculations you did for me for the 10-foot long beam or a 15-foot beam? I already did the math for you. Did it matter? I went, oh my God, you didn't do that. So anyway, and another contractor, I did a structural garage slab, 24 by 24. He did it for 36 by 36. It literally collapsed. And he said, I thought you were conservative. I said, well, yeah, but with those kind of outcomes, I'm not accounting for a 5 times increase in the loads. So anyway, those are just 2 of all kinds of properties that I deal with every day. And I take those materials we saw before, analyze them, and do stuff. So this last year, I had the opportunity of having a BMI grad as an intern and then as a stay with me for a year. Being a very small firm, I knew he was going to be launching someplace. He's out in Atlanta having a good time. But it was very fun because he was doing a trust analysis for me. And he said, the moments are too big. And I said, okay, well, no, the trust should have hidden connections. And I was able to guide him into doing the right thing. And then I remember back 30 years ago, when I did exactly the same thing, and my mentor at the time did the same thing. I was talking with one of our field reps when I was working in Texas, and he said, Dan, the retaining wall is moving like 6 inches every 2 hours. Wow. The long story, but there was about a 90% and we were just starting to build a wall, and it was moving out, and I said, this is not our problem, this is the DOT needs to address this. They did, they said, it's your problem. The next day, it moved out instantaneously. I think it was 12 feet out and 8 feet up, and they almost lost the bridge. And so, experience is great. You can see stuff coming, and you know it's going to happen, and you can predict it. And it's been fun now with this many years of experience. Somebody will call me with a problem. I say, is this happening? And gee, how'd you know that? Well, I've seen a few of them. So, experience is great. So, what else do I do? I use my knowledge of current codes and engineering standards to ensure compliance with the latest requirements. And this is only the small list, but it's the IBC, which is the general building code for a building like this. The IRC, which would be for residential. AISC is the steel code. ACI is the concrete code. NDS is the wood code, and ASHTO would be for highways. When I made a major career shift in 1995, and I started doing residential and commercial buildings, I could design any building in Virginia with these two books. In 2009, this is what I had to design with. A little bigger. In 2012, I gave up. I just got an electronic copy of it. This is crazy. So my world, like everybody else's world, is getting more and more complex. A few years ago, the basic wind codes and seismic. So again, in 1995, this was, let's say, wind, seismic, all the different loads that apply to the structures. I got it from this. That's what it is today. So we still have wind, we still have seismic. What changed? Well, the analysis is crazy. So we really are going to a world where computers are mandatory. It's almost impossible to do it by hand. So every 3 years, they've gotten into the great routine of completely changing these documents. So it's not like I can just say, okay, well, I know this. No. From here to here, they went from what's called working stress to load resistant factor design. And they took factors that you apply later in this version, and they put them at the front end here. And then it started saying, oh, our windows just went up by 60%. No, they just threw a coefficient earlier. It used to be later in the equation. So anyway, there's opportunities. I protect the public above all else. My 18-year-old son was appalled. I'm taking him to the introduction to his college, and I'm walking by a steel column, and as a construction engineer, I tapped on the steel column, and instead of hearing ping, I heard whop, and what is going on? So I checked it out, looked around, he said, Dad, don't do this. He went off to orientation, went back out there, and I went down, and I could put my hand inside the column. And I went over to another column, same thing, another column, same thing. It was like 80-foot tower. It's on the college's brochures for the college. I can put my hand inside the columns. So I have to tell somebody this. Other people, there are thousands of people that walk by that structure every day, but not a PE. So I contacted their maintenance department and said, we got this problem, and they didn't want to hear it. But I kept calling. They finally got a forensic engineer. And guess what he told them? You got to take it down. They did. So, whether my son wanted to hear that or not, he had to do it. Another time I got a phone call. A reviewing engineer said, you're not getting the numbers you're getting on your spreadsheet now. I'm like, okay. I pop open Excel, pop it up. I divide by the length of this bearing angle twice. There was no reason to do it by twice. There's only once. There was actually twice as much stress in this angle. I'd use an Excel sheet of 5 buildings. I didn't sleep that night. I was breaking through numbers, looking back. Thankfully, it was only that building that mattered. And I called my client the next morning, 8 in the morning, and said, we got an issue. I made a mistake. And we resolved it. And we wrote the mistake. But it's a case where, it doesn't matter my reputation. If somebody get killed by, a panel falling off the building because I was too proud to say that now. It's not acceptable. So, my daily, my daily life is lots of projects. In basically a solo practice, I do over 200 to 270 projects a year. Some are really small, some are bigger, but they all have these in common. There's a starting point for the client, inquiry, a proposal that I develop that say, okay, these are what I think you need. Here we go. An investigation. Sometimes it's a case of a school south of here. They were noticing tremendous cracking in their building. We need help. They developed a proposal. We went and did an investigation. When you're doing an investigation and you drill into something and you think you hear the crunch of metal, you're supposed to hear concrete. It turns out it's for the pop pin from builders. Instead of putting the concrete in there, you know you got a problem. Results come in the form of calculations. So I'm doing analysis all the time. I'm doing a report or a set of plans. If you look at the information I have over there, I've got a set of plans that I'm working on currently, some journals of how I keep informed, and just some tidbits of some of these other materials. And then there's a review. Sometimes in a solo practice, I have to go outside. I would go to another professional and say, hey, will you spend some time with me? And then finally, there comes construction or implementation phase. As you can imagine, if I've been practicing on my own for 20 years, I'm doing over 200 a year. That's way too many projects in the next 8 minutes. So here we go. We're just going to look at some of the more interesting ones. My very first architectural precast project was the Oracle building in Reston. The architect decided that the joints that you see shouldn't be at the column. They should be 6 feet off of that. And the structural engineer of record for the building said, oh, you can't put the precast weight on the slab. You have to figure something else out. I'm like, what else do I look into? And anyway, long and short, we ended up, it was probably the most complicated job I've done, even though it looks very minor. A later job, King Farm, we did 3 buildings up there. They won many architectural awards. I worked with a precaster who's phenomenal. Learned a ton from him. But I've done probably in the order of 50 buildings of this magnitude, where I'm not the engineer of record for the building. It's the cladding. So that's my responsibility is limited to that. My son worked for me throughout his, actually from 11 to 21. We did all kinds of neat stuff together, one of which was a big section of 275 around Cincinnati. We did the sound walls. We worked on those. And literally, one of the days I was working on this, I also went to grandmother's basement and felt the cracks in her wall to assure her that she was okay. So that's kind of the range of projects I do. When I was in college, I got an offer from a Texas firm. They were doing 5 nuclear power plants. 3 Mile Island happened a month later. They were no longer doing nuclear power plants. But I did get to work on one finally, Vogel 3 and 4 in Georgia. There's a 55-foot deep well. The concrete walls are 2 foot thick. In order to meet all of the requirements, they had to have a permanent shoring. I designed the permanent shoring for them. So, out of my basement. ICC connector. Has anybody been up on in Maryland? There's I think 4 sections. I did all the retaining walls in B and C, sections A and C. One of the more interesting ones is I've been to Tule Greenwood 3 times. We are working on another antenna support and corridor to that. If you look at this unit, that's looking at the Russians. So whether they know it or not, we're there. Long history on tooling. It's a really interesting area of permafrost. I've learned a ton of an interesting project. And there's a book that Peter, the guy that wrote 1 Minute Manager. He also wrote Liberation Management, which was a bunch of junk, but there was one key point that was really good. Big companies are potentially a thing of the past. The idea of experts coming together from all over, coming together, do a project, and then you explode and go and do other projects with other experts and other projects. So I'm a structural engineer out of Front Royal. The geotech was out of Fairbanks. The electrical engineer was out of Florida. The prime contractor is out of pretty fun. With the fracking industry in Pennsylvania, there's 8 get across the creek, so I worked with a lot of them on creek projects. This is a project, actually, this is a project, I number each of my projects by year. So this is ET 17-001, Ashburn Farm. They have 28 miles of hiking trails in that subdivision. And they have bridges. Their problem is the bridges are 20-year-old pressure-treated timbers that are starting to go. And they can't get their snow removal equipment across the bridges. And so they've contracted with me to do a design for that. And this is my concept. You've heard of segmental concrete bridges. This is a baby one because they can only get very small equipment in. So we're going to end up putting 10 of these segments. Then we use Dewey day rods to tie the bridge together. It sits on a steel beam temporarily. The steel beam is dropped out, pulled out, and you have that bridge. So how did I get here? Okay, I got 3 minutes. University of Minnesota grad. Graduated with a bachelor's in 1980. As it worked out, I believe I took almost every structural course that was available and geotechnical course. At the time, the program was rated number 10 in the country. I received a very good education. I don't know if you're familiar with the University of Minnesota, but my geotechnical professor, Professor Crouch, eventually became the dean of the College of Science and Engineering. So I'm sitting in a 4th level geotech course. You had to be in your spring of your senior year to possibly have had all the prereqs to be in that course. He came in absolutely red-faced, threw some papers down, and he said, "We have 2 students who chose to work together on their take-home test." And then just, there's like tension in the air. He said, "I won't mention their names to you, but those 2 students are out of the Institute of Technology," which was what it was called at the time. They're out of the University of Minnesota. Definitely could have heard a pin drop. And it showed us very quickly engineering is a profession of integrity. And he meant that at the University of Minnesota. And he became the dean. And wow, I was like, I'm so glad I was not one of those 2 students. So, we talked about experience. Wow. There's nothing like it. And I spent about a full year working for Fowler and Hanley. And, just a great opportunity to see real life going on. I went into fluor engineering. There was a boom in the oil industry, and I got to see some amazing stuff. I don't know, I was expecting all the young folks, but I see there's some folks here that are around a while too. You might remember the oil embargo in the 1970s. Part of the solution there was that the U.S. petrochem companies were buying the sour crude as well as the sweet crude from Aramco. It generated this huge boom, which I became a part of, to put in sulfur units in all the domestic petrochem plants around the country. I came in right at the end of the gas program for Saudi. If you can believe it, before 1980, Saudi simply burned off all the natural gas that came out of their oil wells. They had these giant flames in the sky, and they finally, by 1980, I was involved in Barry, Euphemia, and Shedgum, the farthest ones on the right. And then I worked, my first opportunity really to get in the field, literally get on and touch stuff. We were, I think it was the 7th process in this site that Exxon had done. So we were back out looking at stuff that was 60, 70 years old. And I got to find out what corrosion looks like. South Texas. So anyway, amazing opportunity. Go back to this slide, the very last line. The highlight, however, was the fact my immediate supervisor was an incredible engineer and mentor. He took me from a staring green kid to someone with the ability to logically think through problems and reach real solutions. And I could never pay him. I mean, that was my master's right there. And a wonderful guy. Picture this. He's done all of his bachelor's and master's work here in the States. He's from Taiwan. His roommate So his accent was Taiwanese, West Texas.
Wow.
It was amazing. Wonderful guy. He was the guy I mentioned that walked in my office and said, "Oh, you did that wrong." In 20 seconds, he knew, I had done a 12-story structure wrong because of his experience. And that was the experience I had 30 years later with my intern. It was fun. I spent 12 years with this company, the Reinforced Earth Company. And as you can see, over the course of the next 8 years, I progressed from design engineer, engineering manager to central region, engineering manager, Western Division, and then the reason I'm up here is I was promoted to director of engineering in 1991. I had a phenomenal team in Texas. We really worked integrated operations, construction, sales. It was great. I walked out, just as I walked out the door, my boss in Texas said, "Dan, it's not quite the company you think it is." I came up to Virginia and I got introduced to company politics. I'm like, oh no. So it was very interesting, but I got opportunity to manage 35 people. I had to fire about 20 people. We doubled our production. Automation was coming in. We had a young guy from MIT, a sophomore, that wrote a software that I eliminated an entire department thanks to his work. Okay, get the sign here. That structure is a standard section of earth reinforcement that I used over and over again for those 12 years. And this would be your welcome. This is DART. It is a project in the Mockingbird Station in Texas. And here's where I am today. And so, in the course of all that background, and pretty much a solo practice, I get the craziest calls from past experience. I'm all over the country. I might be in Brown's basement one day. I might be designing a beam for a single contractor at a residential project. Who knows? But the opportunities, again, because of that experience, because of mentors, has been great. So, okay, what do we do from there? How about you guys? What's your takeaway? Study math. You did that already. I went into University of Minnesota. Apparently, I didn't know calculus. I didn't know trig. I didn't know algebra. I didn't know geometry. And I'm in calculus. 5 semesters of calculus. I almost died. But I went from C's to A's. I was learning it all at the same time. Not a good thing. I also learned, as today, you have to be able to present oral arguments about what you want to do, about what's right. So all the courses in engineering, the idea of you were talking about the image of the lab, or the image of the engineer, the nerd with big glasses sitting at a desk. It's not the case. You have to be able to communicate. Integrity. I just took a course I'm registered in Florida on professional integrity. My stories and many other stories. How would you like to be the engineer record for the San Francisco Tower? It's up 18 inches over the last 2 years. Internships, real-world experiences. It's a great opportunity. The rewards are great. And due to the time, I won't do this, but does anybody know who the only president of the United States that was an engineer?
Is it fair if we looked at that?
You're very close.
Is it fair if we
No.
saw it?
No, he comes in second. He never practiced. This is written by Herbert Hoover.
Yay!
All right, very good. And it talks about the profession of engineering. So it's a worthy read. My father gave it to me. It's very fun. So that's it. Thank you.